In this lesson, you will learn about the software-defined WAN feature available on FortiGate. In this lesson, you will explore the following topics: Introduction to Software-Defined WAN, SD-WAN Performance SLA, SD-WAN Rules, SD-WAN Diagnostics. After completing this section, you should be able to identify use cases for SD-WAN, identify the implementation requirements for SD-WAN, configure SD-WAN virtual link and load balancing, configure static routes and firewall policies for SD-WAN. By demonstrating competence in SD-WAN, you should be able to configure the SD-WAN virtual link and traffic load balancing to use multiple WAN links effectively on FortiGate. SD-WAN is a virtual interface consisting of a group of member interfaces that can be connected to different link types. FortiGate groups all the physical member interfaces into a single virtual interface, the SD-WAN interface. Using SD-WAN simplifies configuration because the administrator can configure a single set of routes and firewall policies and apply them to all member interfaces. There can only be one SD-WAN interface per VDOM. One of the main motivators for deploying SD-WAN is effective WAN use when you are using multiple WAN links. Effective WAN use is achieved using various load balancing algorithms such as bandwidth usage, sessions, or application-aware routing. Another important feature of SD-WAN is link quality measurements. Using ping or HTTP echo, FortiGate can determine the latency, jitter, or packet loss percentage for each link and dynamically select links based on these measurements. This ensures high availability for business-critical applications. Now you'll learn about SD-WAN use cases. In the example shown on this slide, the customer depends heavily on expensive, inflexible MPLS. All the traffic is routed through the MPLS circuit to the provider cloud, then to the public cloud or internet based on the applications. As mentioned earlier, there is no flexibility in this scenario, and yet it is an expensive solution for the customer. How can the customer add redundancy, flexibility, reliability, and most importantly, security without adding costly infrastructure? You will learn about the solution in the next slides. In the example shown on this slide, the customer would like to keep MPLS for business-critical applications while adding flexibility and redundancy. MPLS is being used to send business-critical traffic, for example, voice and video, based on the best path with less delay, jitter, or packet loss. In case the current path degrades below policy threshold, business-critical traffic will be rerouted to a new tunnel. Also, non-critical traffic is load balanced across different lines to maximize bandwidth or minimize cost. At the same time, the branch can have direct secure access to the internet, which improves the cloud application performance, and can load balance SaaS and IaaS content if needed. In the example shown on this slide, costly MPLS is replaced by 2 internet VPN tunnels, and yet gains robust resiliency and redundancy. By replacing MPLS, the customer can minimize cost while maximizing quality. The SD-WAN solution is a network application-aware solution and dynamically selects the best WAN to maintain higher SLA. When you configure SD-WAN, you must specify at least 2 member interfaces and their associated gateways. You should configure SD-WAN early during the initial setup of FortiGate because if an interface is already referenced by a firewall policy or static route, you cannot use it as a member interface. If you intend to use an interface as an SD-WAN member, and that interface is being referenced by a firewall policy or static route, you must delete the associated firewall policy and static route before you can assign that interface as an SD-WAN member. SD-WAN supports physical interfaces as well as VLAN, aggregate, and IPsec interfaces. You can also easily add another member interface at a later date to add more bandwidth or QoS options. FortiGate groups all the member interfaces into a single virtual interface, the SD-WAN interface. Using SD-WAN simplifies configuration because the administrator can configure a single set of routes and firewall policies and apply them to all member interfaces. There can only be one SD-WAN interface per VDOM. In FortiOS version 6.0, an implicit rule is automatically generated when you enable SD-WAN. If none of the conditions for any of the other rules are met, then the implicit rule will be used. This implicit rule is simply designed to balance the traffic among all the available SD-WAN member links. We will talk about SD-WAN rules later in this lesson. SD-WAN load balancing uses traffic distribution methods that are similar to those used by Equal Cost Multipath, ECMP. However, SD-WAN link load balancing includes one more balancing method: volume. SD-WAN link load balancing uses these methods. Source IP. Traffic from the same IP address uses the same link. Source destination IP. Traffic from the same pair of source and destination IP addresses uses the same link. Spillover. This method is similar to the spillover method used by ECMP. A link routes all the traffic until the volume reaches a threshold. After that, another link is used. Sessions. The interface weights determine the proportion of sessions that each link should handle. Sessions are distributed among the links based on the interface weights. Volume. The interface weights determine the proportion of traffic volume that each link should handle. Sessions are balanced so that traffic volume is distributed based on the interface weights. After you have enabled SD-WAN and configured the member interfaces and the load balancing method, a logical interface with a name SD-WAN is automatically added to the interface list. Next, you must create the routes and firewall policies using this virtual interface. You must still configure a default route when implementing SD-WAN. The default route configuration using the SD-WAN interface does not require a gateway address because FortiGate will forward packets to the appropriate gateway based on the member interface gateway information. When using SD-WAN, you do not need to configure multiple firewall policies for individual member interfaces. Firewall policies created with the SD-WAN interface allow traffic to be forwarded through any member interface. Even though you must configure routes using the SD-WAN virtual interface, FortiGate installs individual routes for the member interfaces in the routing table. These routes share the same attributes, destination address and subnet, distance and priority, and are both active. This allows FortiGate to remove individual routes in the event of an interface outage and redirect all traffic to the remaining member interfaces without affecting the whole SD-WAN load balancing group. Good job! You now understand the SD-WAN feature on FortiGate. Next, you'll learn about the SD-WAN performance SLA and link quality measurements. After completing this section, you should be able to configure SD-WAN performance SLA, identify how FortiGate measures link quality. By demonstrating an understanding of SD-WAN performance SLA, you should be able to configure SD-WAN performance SLA and identify how FortiGate measures link quality. In FortiOS version 6.0, the SD-WAN status check has been renamed to Performance SLA and includes feature enhancements. Now you will learn about the two parts that make up the Performance SLA window: the Link Health Monitor or status check and SLA targets. The Link Health Monitor is a mechanism for detecting when a router along the path is stopped or degraded. In FortiOS version 6.0, the SD-WAN status check has been improved and renamed Performance SLA, and it can be created for specific link members rather than the SD-WAN virtual interface as a whole. FortiGate can check the status or health of each SD-WAN member interface participating in a Performance SLA by periodically sending probing signals through each member link to a server that acts as a beacon. You can specify up to 2 servers to act as your beacons. This is to guard against the server being at fault and not the link. The GUI provides 2 protocol options with which to perform the status check, ping and HTTP, but in the CLI you have 5 options. Those options are ping and HTTP, as in the GUI, but also TCP echo, UDP echo, and two-way active measurement protocol, TWAMP. The Performance SLA Health Checks measures the quality of the links connected to the member interface participating in a Performance SLA. 3 different criteria are used for this measurement: latency, jitter, and packet loss percentage. It's these values that are used against the SLA criteria within the rules that are used to route traffic based on the link quality of each member. The packet loss, latency, and jitter that are displayed are based on the replies, averaged over a short period, from the server that the Performance SLA is using. The system will start with the first server. If that server becomes unavailable, then it will switch to the second server. It will stay with that second server until it becomes unavailable, at which point it will go back to the first server. If both servers are unavailable, then that Performance SLA is deemed dead. It is important to note that the green up arrows are indicating only that the server is responding to the health check, regardless of the packet loss, latency, and jitter values. It is not an indication that any of the SLAs are being met. The quality of service for the traffic associated with this Performance SLA is defined by the SLA targets. An SD-WAN member link assigned to this Performance SLA must meet the SLA target in order to be selected over the other participating links. You can configure the latency, jitter, and packet loss thresholds to meet your needs, and create granular SLA targets to fine-tune the SD-WAN for specific applications. Although SLA targets are specified on the Performance SLA page, they are not actually used there. The values configured there are used only when referenced by a rule. You can create multiple SLA targets per Performance SLA, although there are few scenarios in which you would want to do that. For example, you are located in a branch office and use a few different applications that run on the same server headquarters. You could create one Performance SLA that will perform the health check on that server, but then have different SLA targets for the different applications. You could make the rules for some apps lenient, but more strict for others. If, however, the applications are running on different servers, then you would want to create different Performance SLAs for each application in order to have the health check go against the specific application server. And each Performance SLA would require only one SLA target for that application. This is also where you can set how often the system checks the link status to determine if it needs to transfer the traffic to another link. The failure before inactive and restore link after settings are to help prevent the system from continuously transferring traffic back and forth between links, a condition known as flapping. The CLI commands for configuring Performance SLA provides more options. The TCP echo, UDP echo, and TWAMP options are only available on the CLI. These options provide different methods of measuring round-trip network performance between any 2 devices that support them. There are other CLI-only options that are available only based on the Performance SLA protocol you choose. For more information on these options, refer to the CLI reference guide on docs.fortinet.com. You can configure the warning and alert thresholds for the latency, jitter, and packet loss quality checks. These are also not available on the GUI. You can also configure multiple SLA targets with different values on both GUI and CLI. Good job! You now understand SD-WAN Performance SLA. Next, you'll learn about SD-WAN rules. After completing this section, you should be able to identify SD-WAN rule matching criteria, configure dynamic link selection based on link quality, By demonstrating competence in SD-WAN rules, you should be able to configure dynamic link selection based on link quality to ensure high availability for business-critical applications. SD-WAN rules allow you to specify which traffic you want to route through which interface. You can configure the SD-WAN rules to choose the egress interface based on a link's latency, jitter, or packet loss percentage. The rules are evaluated in the same way as firewall policies, from top to bottom using the first match. The following parameters can be used to match the traffic: source IP address, destination IP address, destination port number, ISDB address objects as destination, users or user groups, type of service, TOS. SD-WAN rules offer great flexibility when matching traffic. For example, you can route Netflix traffic from specific authenticated users through one ISP, while keeping the rest of your internet traffic through another ISP. Starting in FortiOS version 6.0, SD-WAN can use the Internet Services Database as well as the Application Control Database to steer applications along a specific link. FortiGuard continuously maintains and adds to these databases, and FortiGate periodically gets an updated copy. When using application control, you should enable SSL inspection for the most accurate application identification. The best quality strategy is based on the performance of the network. In the example shown on this slide, WAN 1 and WAN 2 are included in the interface preference. So WAN 1 will be used, since it is the first on the list, until the quality criteria of that network is 10% worse than that of WAN 2, at which point WAN 2 would take over. By default, the quality criteria is 10%, but you can change it on the CLI using the set link cost threshold command. Note that you don't use any of the SLAs here. The quality check on the performance SLA, DC, PBX, SLA, is only using the server information, health check, against the quality criteria. You can use the options of latency, jitter, and packet loss percentage. You can also use the bandwidth options, downstream bandwidth, upstream bandwidth, or bidirectional bandwidth, so that FortiGate selects the link based on the available bandwidth of incoming, outgoing, or bidirectional traffic. This is useful because users may use some applications primarily for downloading and other applications primarily for uploading. The last option, Custom Profile 1, allows you to base the link selection on a combination of its criteria values. The link quality will be determined by the equation. The larger the value, the more weight that criteria will have in the selection. Leave the weight value at 0 to exclude that criteria from the equation. With a minimum quality SLA strategy, you select an SLA target from a performance SLA that you want to measure the traffic against. Note that even if a performance SLA has multiple SLA targets, you can only select one of the SLA targets from that particular performance SLA. A few things to note on the link selection process. The links are evaluated from the top down, as listed in the Interface Preference field. So if all links satisfy the SLA, the first link will be used even if that link is technically not the best quality link. If the current link no longer satisfies the SLA, then FortiGate will go to the next link and see if it can satisfy the SLA. If not, it will go to the next one and so on. If no link can satisfy the SLA, then it will use the first link, preferred link, regardless of its performance. The system will check once per second to see if any of the links meet the SLA. If after 5 consecutive times one link can meet the SLA requirements, then that link is used. If more than one link meets the SLA requirements, then it will select the link according to the configured order of preference. Application-specific rules are evaluated in the same way as the firewall policies, from top to bottom using the first match. An implicit rule is automatically generated when you enable SD-WAN. If none of the conditions of any of the other rules are met, then the implicit rule will be used. This implicit rule is designed to balance the traffic among all the available SD-WAN member links. Double-clicking on the implicit rule will display the load balancing options. Similar to ISDB routes, SD-WAN rules function as policy routes. They take precedence over any other routes in the routing table. Good job! You now understand SD-WAN rules. Next, you'll learn about SD-WAN diagnostics. After completing the section, you should be able to monitor SD-WAN link usage, monitor SD-WAN link quality status, verify SD-WAN traffic routing. By demonstrating competence in SD-WAN diagnostics, you should be able to maintain an efficient and effective SD-WAN solution. You can use the SD-WAN usage monitor to view traffic distribution between the member interfaces based on bandwidth or volume. The volume view gives a better representation of the traffic sent and received across all the member interfaces, whereas the bandwidth view shows you how much bandwidth each interface is using as a result of the sessions passing through them. The Sessions view shows number of sessions passing through per each interface. Because link quality plays a big role in link selection when using SD-WAN, monitoring the link quality status of the SD-WAN member interfaces is a good practice. Any prolonged issues with packet loss and latency should be investigated to ensure your network traffic does not experience outage or degraded performance. Green arrows indicate interfaces are active in the SD-WAN group. Red arrows indicate that the interface is inactive for that specific status check. FortiGate will also generate system event logs when an SD-WAN member interface's route is removed or added to the routing table. Use system events to investigate any route failovers. You can use the Destination Interface column in the forward traffic logs to verify that traffic is egressing the SD-WAN member interfaces. Alternatively, you can use verbosity levels 4 and 6 to view the egress interface using the CLI packet capture tool. Congratulations! You have completed the lesson. Now you will review the objectives that you covered in this lesson. This lesson covered the following objectives: identify use cases for SD-WAN, identify the implementation requirements for SD-WAN, configure SD-WAN virtual link and load balancing, configure static routes and firewall policies for SD-WAN, configure SD-WAN status check, identify how FortiGate measures link quality, identify SD-WAN rule matching criteria, configure dynamic link selection based on link quality, monitor SD-WAN link usage, monitor SD-WAN link quality status, verify SD-WAN traffic routing. By mastering the objectives covered in this lesson, you have gained the skills and knowledge that you need to configure, maintain, and diagnose your FortiGate's SD-WAN solution.